Again here, so welcome to another lecture series. So in this lecture, we're going to discuss power of secant and then tangent. Okay. So last time we discussed power of sine and cosine. So for this discussion, so we're going to discuss the cases with integrands of secant and then tangent. So for the first case, so we have here an even exponent of secant and even exponent of tangent. So how do we do this? So for case number 1, so even secant exponent so what we're going to do is to isolate one secant squared theta or whatever angle and then change the remaining secants to tangent. By means of identities. Alright. So for this case, let's isolate one secant squared first and rewrite the equation. So we have integral of secant squared x, tangent squared x, and the isolated secant squared x. So we have our secant squared x dx. Alright. Then change remaining secants to tangent. So what's the identity of secant squared x? Recall the identity 1 plus tangent squared x is equals to secant squared x. So therefore, we can change this to 1 plus tangent squared x. So therefore, we have integral of 1 plus tangent squared x, tangent squared x, secant squared x, dx. Then let's distribute this. So we have integral of tangent squared x plus tangent raised to 4th x, then secant squared x dx. Alright. So if you use u substitution and we let u be equal to tangent x, the derivative of tangent x is equal to secant squared x. So therefore we have your secant squared x, so we can now substitute that. Don't forget dx. So therefore we have integral of u squared plus u raised to 4th quantity du. Then let's substitute or let's distribute, I mean. So integral of u squared du plus integral of u raised to 4th du. Alright. So this is basic power rule. So we have u raised to cube all over 3 plus u raised to 5 all over 5 plus c. Then back substitute u. So therefore we have tangent cube x all over 3 plus tangent raised to 5x all over 5 plus c. And that's how we get the answer for that integral. Alright, for sample problem number 2, so this is case number 2. As you can see, we have here tangent cube x, so this is the 3x, all over square root of secant x. Alright, so for case number 2, the power of tangent is odd. So if we have power of tangent is odd, so we isolate one secant and one tangent. Alright, so let's demonstrate the case. So for this one, let's first rewrite this. So we can write this as integral of tangent cube x secant, so this is negative exponent, negative 1/2. So negative 1/2 x dx. So we need to isolate one secant and then one tangent such that we can write this as tangent squared x. Then if we're going to isolate one tangent here, or one secant here, so that would be secant of negative 3/2, since that would be 2. Alright. So secant negative 3/2 x. Then the isolated tangent and secant will be written as tangent x, secant x dx. Alright. So if we now use the u substitution, so after we isolate one secant and one tangent, we change the remaining tangent into secant, just like what we did with case number 1. Alright, so therefore, this can be written as tangent squared x, going back to our identity, is secant squared x minus 1. So therefore, we have here secant squared x minus 1 quantity, secant negative 3 halves, x, then tan x, sec x, dx. Alright, distribute, so this is 3 halves. So we have integral of secant of negative 3x, and this is minus secant of negative 3 halves of x. And tangent x, secant x, dx. So if we let u be equal to secant x, the derivative of secant x, which should be du, is equal to tangent x, secant x, dx. And we can apply the substitution in this equation. So, we can substitute everything here, such that we can write the equation as the integral of u raised to negative 3 minus u raised to negative 3 halves quantity du. Alright. So, rewrite this. So, that would be integral of u raised to negative 3 du minus integral of u raised to negative 3 halves du. Alright. So, power rule. So, u, negative 3 plus 1. So, we have u raised to negative 2 over negative 2 minus, this would be plus 1. So, we have u raised to negative 3 halves plus 2 all over 2 all over negative 3 halves plus 2 all over 2 plus c. Alright. So, this becomes negative u raised to negative 2 all over 2. Then, we have here 1/2 and 1/2. So, negative 1/2. So, this becomes plus. So, we have here 2u raised to negative 1/2 plus c. Okay, so let's double check first. So, we have here negative 1/2. So, if we have here negative 1/2, 2 is based on the numerator. So, plus 2u raised to negative 1/2 plus c. So, back substitute everything. So, we have negative. So, secant x, negative 2x all over 2 plus 2 secant of negative 1/2 of x plus c. And that is now the integral of that function. Tangent, so we have here secant x, tangent squared x. So, this is a special case. So, we cannot isolate one function to another, but rather will apply our previous lesson, which is integration by parts. Alright, so how do we do that? So first, let's try to integrate it normally. So if we're going to transform tangent squared x to secant, so we'll have integral of secant x multiplied by secant squared x minus 1 dx. Distribute. So we have integral of secant squared, or rather secant cube x minus secant x dx. So that will have integral of secant cube x dx minus integral of secant x dx. Alright. So secant x dx is directly integrable. So let's leave this behind for a moment, or let's set this aside for a moment. So this is the integral of secant cube x dx minus ln of secant x plus tangent x plus c. Alright. So we can ignore the arbitrary constant for now, since we still have an integrand here. Alright. So we'll apply integration by parts here. So we'll isolate one secant and then the rest would be secants. But if you observe, it just converges and then it repeats itself. So we can let this be equal to I. So with that, so that would be secant x and then secant squared x. So if we let u be equal to secant x, the derivative of secant x is secant x tangent x dx. And then if we let v be equal to secant squared x, the integral of secant squared x, or rather dv, the integral of secant squared x is simply equal to tangent x. So don't forget dx here. So if we're going to back substitute that with the formula, so that would be, this will be written as I is equal to uv, so secant x, and then tangent x, minus the integral of v, which is tangent x, and then du is secant x, tangent x, dx, which just return to that equation. So we have I is equals to secant x, tangent x, minus integral of tangent squared x, secant x dx. And we know that we have integrated it like this. So we have I equal to secant x, tangent x, minus quantity, the integral of secant cube x dx, minus ln of secant of x plus tangent of x. Then that's it. Alright. So we know that secant cube x dx is I. So therefore, we'll replace that with I. So that I is equals to secant x, tangent x, minus quantity I, minus ln of secant x plus tangent of x. Distribute negative sign. So we have I equals to secant of x, tangent of x, minus I, plus ln of secant x, tangent of x. Alright. Transpose I to the other side. So we have 2i equal to secant x, tangent of x, plus ln of secant of x plus tangent of x. Alright. So that we can further write I is equal to 1/2 secant of x, tangent of x, plus 1/2 ln of secant of x plus tangent of x. Inject the value of I on our original equation. So we have 1/2 secant of x, tangent of x, then 1/2 and 1, so that would be negative 1/2 ln of secant of x, tangent of x, so plus here, and then an arbitrary constant plus c. And that is now the answer to that integration problem. So that's case 3. So hope you learned something new in this video. So if you learned something you enjoy this video, so please don't forget to like and subscribe. So see you on the next lecture.